Welcome to Naradar Academy. In this video, we are going to discuss various methods for solving first order differential equations. First, let's see what are the methods available. Then we'll do problems based on these types. The first one is variable separable method. So here the equation will take the form f of x dx plus g of y dy equal to 0. See, here f of x is purely a function of x and g of y is purely a function of y. So just by direct integration, the solution can be obtained. Okay, so this is called variable separable method. The next one is, suppose if the given equation is of the form dy by dx is equal to f1 of xy by f2 of xy. Here f1 and f2 are homogeneous functions of same degree. Okay, dy by dx is given by f1 by f2 where f1 and f2 are homogeneous functions of same degree. In that case, the solution is obtained by making the substitution y equal to vx. Okay, so differentiating this, what will you get? Dy by dx is equal to, this v is also a function of x. So, v plus x into dv by dx. So, substituting this in the given equation, it will reduce to variable separable method with variables v and x. Okay, so this is the second method for solving first order equations. Then the third one is a slight variation of the second method. In the second method, you have homogeneous functions. No, numerator and denominator are homogeneous functions of xy. Here they are not homogeneous functions. Okay, dy by dx is equal to ax plus by plus c. This is capital C by small letters ax plus by plus c. That is, not, they are not homogeneous. Okay, here we have a constant capital C and small c is here. So in that case, we are going to make this as a homogeneous functions of xy, and then we are going to solve by using the second type. So for this, what substitution we are going to make here? Let small x is equal to capital X plus h and small y equal to capital Y plus k. So by making this substitution, the equation reduces to dy by dx. Here everything is in terms of capital letters. Dy by dx is equal to just simply a capital X plus b capital Y divided by small a capital X plus small b capital Y. No c will appear here. Okay, they will get eliminated by making this substitution. So this equation becomes like the second type, that is f1 of xy, homogeneous function in the numerator and denominator, and which can be solved by this method. Okay, right. So after finding the solution in terms of capital X and Y, we have to write the solution in terms of small x and y. For that, we should know what are the values of this h and k, no? So for that, we have, see, h and k are variables such that ah plus bk plus c equal to 0, and another equation is ah plus bk plus c equal to 0. By solving these two equations, we will get what is h and k. So by substituting the values of h and k, we can get the solution of the original problem. Okay, this is the third one. Then fourth one is the equations of the type dy by dx plus py equal to q, where this capital P and Q are purely functions of x. There will be no y terms in P and Q. Okay, here P is the coefficient of y and Q is the function of x which is appearing on the right hand side. So in this case, the solution is given by y into e power integral p dx is equal to integral q e power integral p dx plus c. And this e power integral p dx is called the integrating factor. Suppose equations of this type is given, and if you have to find out the integrating factor, simply find e power integral p dx. This is called integrating factor of the given equation, and this one is the solution. Okay, right. A slight modification of this equation is Bernoulli equation. The difference is here on the right hand side you will be having q, function of x only, but if along with q you have some y power n, then that equation is called Bernoulli's equation. So this is solved by making a substitution z equal to y power 1 minus n. Here y power n, if y power n appears on the right hand side, take z equal to y power 1 minus n. Then this equation reduces to dz by dx plus p into 1 minus n into z equal to q into 1 minus n. So no No z terms here, no. So this equation reduces to the previous type, which can be solved by this. So you will obtain the solution in terms of z, then you can again revert the substitution, will get the original solution for the given problem. Okay, so these are the different types. One more type we have, that is by using exactness of the differential equation. See, suppose if the given equation is of the type m dx plus n dy equal to 0, then this equation is said to be exact when this condition is satisfied. Dou m by dou y equal to dou n by dou x. If the equation is exact, then directly we can write the solution as integral m dx plus integral n minus dou by dou y integral m dx. This is nothing but this term. Okay, you are taking this term, differentiate with respect to y and subtract it from n, and then integrate with respect to y plus c. So this is the final solution. So when you will write this as the solution, when the given equation is of the form m dx plus n dy equal to 0, along with the condition dou m by dou y equal to dou n by dou x. Okay, right. Suppose if an equation is given like this, but this condition is not satisfied, means that equation is not exact. But we can make it exact by multiplying it with the integrating factor. So what are the integrating factor? The integrating factor depends on the condition of the given equation. Suppose the same equation m dx plus n dy equal to 0 is given. This condition is not satisfied, but mx plus ny is homogeneous. In that case, the integrating factor is 1 by mx plus ny. That means you multiply this equation with 1 by mx plus ny, then obviously this condition will be satisfied and you can write this as the solution. And second case, if the given equation is of this type, that is f1 of xy into y dx plus f2 of xy into x dy equal to 0. See here, this is not x comma y, product xy I have written here. That is, if the function, the given equation is like some function of xy, product xy into y dx plus again some function of product xy into x dy equal to 0, the integrating factor is 1 by mx minus ny. Then in that case, what you have to do? Multiply the given equation by 1 by mx minus ny. It will become exact and the solution is given by this equation. Right? Then third one is, if 1 by n into dou m by dou y minus dou n by dou x is purely a function of x, say that value is f of x, then the integrating factor is e power integral f of x dx. Okay. The another case is 1 by m into dou m by dou y minus dou n by dou x is purely a function of y alone. Say it as f of y. In that case, the integrating factor is e power integral f of y dy. Okay, we can easily identify the exactness and the conditions which it will satisfy. See, here this is the given equation, no, m dx plus n dy equal to 0. So, with the given equation, first you check whether the equation is of this type. That is, f1 of, first one is function of xy into y dx and function of xy into x dy equal to 0. Then 1 by mx minus ny is the integrating factor. Multiply the given equation by 1 by mx minus ny and write the solution like this. If it is not like this form, then check the condition for exactness. If it is exact, directly you write the solution. If it is not exact, then you find this term, that is dou m by dou y minus dou n by dou x. Okay, by looking at this, you can arrive whether it is of this type or this type. This type means what? If you divide it by n, pure function of x. If divided by m, pure function of y. In that case, you can identify whether it belongs to these two conditions and you can write the integrating factor. If these conditions also fail, then go to the last one. Find mx plus ny. You check whether it is homogeneous function. In that case, 1 by mx plus ny is the integrating factor. So this is the order in which you have to identify. So first you can directly check whether it is exact or not. Otherwise you go with this one. Second one or these two things. Finally you go to this one. So this is the order you can check so that it will be easy for you to identify the integrating factor. So after finding the integrating factor, what you have to do? Multiply the given equation by the integrating factor. Then it will satisfy this condition. Okay. Then you write the solution in this way. Okay, that's all. So these are the different methods available for solving first order equations. Now we are going to see few problems based on these types. See, this is the first problem. Solve 1 minus x square into dy by dx plus xy is equal to 5x. Okay, now let's see. 1 minus x square into dy by dx is equal to 5x minus xy. So dy by dx is equal to, you take x outside. So x into 5 minus y by 1 minus x square. Okay, now you bring this y term here. So it will be 1 by 5 minus y into dy equal to x by 1 minus x square into dx. So I have separated the variables. Y terms on the left hand side and x terms on the right hand side. Now directly you integrate and find the answer. So integration of 1 by 5 minus y dy is equal to integral x by 1 minus x square into dx. Now here this is 1 minus x square, no? So if you differentiate, what will you get? 2x. So here only x is there. So multiply and divide by 2 so that it will be easy for us to do the integration. For the sake of integration, I am multiplying and dividing by 2. So here, what is this integral? Minus log of 5 minus y. Here it is minus log of 1 minus x square plus integrating constant log c. Okay, so bring this term to the left hand side. 1 by 2 log of 1 minus x square minus log of 5 minus y equal to log c. So log of root of 1 minus x square minus log 5 minus y equal to log c. This is log a minus log b, which can be written as log of a by b equal to log c. So root of 1 minus x square by 5 minus y equal to c, or root 1 minus x square equal to c into 5 minus y. So I have solved this problem by using the variable separable first method, or else you can do this by what? Dy by dx plus py equal to q is there, no? In that way also you can solve. So in that case you have to divide throughout the equation, you have to divide by 1 minus x square. So it will become dy by dx plus x by 1 minus x square equal to 5x by 1 minus x square. So that is another way of solving this problem. So in any one of the ways you can solve. Okay. This is the second problem. Tan y into secant square x dx plus tan x into secant square y dy equal to 0. By looking at this problem itself, we can see the variables can be separated. Okay, keep this term on the left hand side and bring dy term on the right hand side. So tan y secant square x dx is equal to minus tan x secant square y dy. Bring all the x term to the left hand side. So secant square x by tan x dx is equal to minus secant square y by tan y dy. So take integral on both sides. Now this is purely in terms of x and this is in terms of y. So while taking integration, see, differentiation of the denominator give you the numerator. That is differentiation of tan x secant square x. Differentiation of tan y is secant square y. So the integral value is nothing but log of the denominator. So log tan x equal to minus log tan y plus log c. Whenever you have this in terms of log, you include the integrating constant also in terms of log. Okay, then it will be easy for calculation. So log tan x plus log tan y equal to c. This is like log a plus log b, which can be written as log of a into b equal to log c. So removing log on both sides, will get tan x tan y equal to c. So this is the solution. Okay, then next problem, solve dy by dx is equal to x minus y by x plus y. So see, the variables cannot be separated here. Okay, that is dy by dx equal to x minus y by x plus y, no? Now let us cross multiply. X plus y into dy is equal to x minus y into dx. So x dy plus y dy equal to x dx minus y dx. So x dy, see here x dy is there, here y dx is there. So I am bringing them together. This x dy and y dx equal to x dx minus y dy. So if you look at this, see, x into differentiation of y plus y into differentiation of x. This is nothing but product rule. So differentiation of xy is this left hand side equal to, here the variables are separated, x dx minus y dy. So when you integrate this, integration of d of xy is equal to what? Simply xy equal to integral x dx is equal to x square by 2 minus integral y dy equal to y square by 2 plus constant c. Next one, y square minus 2xy into dx plus, equal to x square minus 2xy into dy. So here separation of variables is not possible. So I am going to write the separation of variables is not possible. So I am going to write it like dy by dx equal to y square minus 2xy by x square minus 2xy. See here, the numerator is y square minus 2xy. No, here y square, that is degree 2. Here also x into y means what? Degree 2. So this is a homogeneous function of degree 2. And similarly denominator also, here x square degree 2, here x into y degree 2. So both numerator and denominators are homogeneous functions of degree 2. So I am going to solve this by method 2 described in the table. So let us take y equal to vx, that is dy by dx equal to v plus x into dv by dx. Substitute it here. So v plus x into dv by dx is equal to v square x square minus 2x into vx divided by x square minus 2x into vx. Okay, right. So throughout we can cancel x square here. So it will be v square minus 2v by 1 minus 2v. Right. Now in the left hand side we have v plus x into dv by dx. Now bring this v to the right hand side. So it will be v square minus 2v by 1 minus 2v minus v. So after simplification we are getting it as 3v square minus 3v by 1 minus 2v. Otherwise x dv by dx is equal to 3 into v minus 1 by 1 minus 2v. So now here the variables can be separated. Bring all the v terms to the left hand side and all the x terms to the right hand side. So it will be 1 minus 2v by v into v minus 1 dv is equal to 3 into dx by x. So now let us integrate. For integrating, this will be, if this is of this type, it will be easy for me to do the integration. So I am taking this as v square minus 2v. Now look at this denominator, v square minus v, no. So when you differentiate this, you will get what? 2v minus 1. The same thing is there in the numerator but opposite in sign. So the integration is minus log of the denominator, v square minus v, equal to 3 into integration of 1 by x is log x plus log c. So 3 log x plus log v square minus v equal to log c. So log x cube into v square minus v equal to log c. So what we get? X cube into v square minus v equal to c. But v is equal to y by x. So x cube into y square by x square minus y by x equal to c. So x cube into, you take LCM here, y square minus xy by x square equal to c, or x into y square minus xy equal to c. That is xy into y minus x equal to c. Okay, now the same problem I have taken here also. This problem I am going to solve by using the method of exactness. See, bring this to this side. So I am having it like m dx plus n dy equal to 0. M is y square minus 2xy and n is minus of x square plus 2xy. Now dou m by dou y equal to 2y minus 2x and dou n by dou x equal to minus 2x plus 2y. So both are equal, no? So the given equation is exact. So when you get the equation as exact, directly you can write the solution as integral m dx plus integral n minus dou by dou y of this m dx dy plus c. So integral, what is m here? Y square minus 2xy dx plus integral n is minus x square plus 2yx minus dou by dou y of integral this value again y square minus 2xy dx dy plus c. So integrate with respect to x. So it is y square x minus 2x square by 2y plus integral minus x square plus 2xy minus dou by dou y of this value is appearing here only. Okay. So this is y square x minus x square y into dy plus c. Now differentiate this with respect to y. So it will be what? Minus 2xy plus x square into dy. Now see, minus 2xy plus 2xy minus x square plus x square. So everything get cancelled. So 0 here. So finally what will get? Y square x minus x square y plus the integrating constant c. So that is what the same solution we have obtained by using the method of what? Homogeneous equation. Okay. So in both the ways you can solve the given problem. Then one more problem we will see. This is another problem. Dy by dx is equal to x plus 2y minus 3 by 2x plus y minus 3. So by looking at this equation, we can say this cannot be solved by separation of variables, and the numerator and denominator are also not homogeneous, because here power 1, here also power 1, but this is of power 0. There is no xy terms, no. So they are not homogeneous. So when you are having non-homogeneous functions like this, you have to make the substitution x equal to small x equal to capital X plus h and small y equal to capital Y plus k. So the given equation will become capital dy by dx is equal to simply x plus 2y by 2x plus y. Okay, where this h and k can be obtained by, here you just replace x by h and y by k and equate it to 0. Similarly in the denominator also solve these two equations so that you can find the values of h and k, but I am not going to use this h and k as of now. I am going to use this only when I am going to replace the solution in terms of small x and y. So keep this apart, we will solve this equation. Now this equation is homogeneous in capital XY, no? So for solving homogeneous equation, we have to take y equal to Vx. That is dy by dx equal to V plus x into dV by dx. So substituting, what will get? V plus x into dV by dx is equal to x plus 2Vx by 2x plus Vx. So V plus x into dV by dx is equal to 1 plus 2V by 2 plus V. Bring this v to this side. So x dv by dx equal to 1 plus 2v by 2 plus v minus v. So by taking LCM, we are getting x into dv by dx is equal to 1 minus v square by 2 plus v. Now we can separate the variables. So 2 plus v by 1 minus v square into dv equal to dx by x. So we are going to integrate this now. For integration, let us split this term by using partial fraction. So 2 plus v by, this is like a square minus b square. So it can be written as a plus b into a minus b. So it's equal to a by 1 plus v plus b by 1 minus v. So by taking LCM, we have 2 plus v equal to a into 1 minus v plus b into 1 plus v. Now we separate the constant terms and coefficients of v and equate on both sides. So we are getting a equal to 1 by 2 and b equal to 3 by 2. So substituting it here in equation number 1, we are getting 2 plus v by 1 minus v square equal to 1 by 2 into 1 plus v plus 3 by 2 into 1 minus v. So now you have to take integration on both sides. So this is 1 by 2 log of 1 plus v plus 3 by 2 log of, here it is only 1 minus v, no? So minus log of 1 minus v equal to log x plus log c. So log of 1 plus v power half by 1 minus v power 3 by 2 equal to log x plus log c. So removing log on both sides, we are getting 1 plus v power 1 by 2, 1 minus v power 3 by 2 equal to cx. So substitute v is equal to y by x. So simply what you are getting, x plus y the whole power half equal to c into x minus y the whole power 3 by 2. So removing that power half, we have to square on both sides. So x plus y equal to c square into x minus y the whole cube. Now you substitute capital X equal to x minus 1 and capital Y equal to y minus 1. So what we get? X plus y minus 2 equal to c square into x minus y the whole cube. That's all. Then next problem, 1 minus x the whole, 1 minus x square into dy by dx plus 2xy equal to x into root of 1 minus x square. Okay, now let us divide this equation throughout by 1 minus x square. So dy by dx plus 2x by 1 minus x square y equal to x by root of 1 minus x square. So this is like dy by dx plus py equal to q, where this is p, 2x by 1 minus x square and q equal to x by root of 1 minus x square. The integrating factor is e power integral p dx. So e power integral 2x by 1 minus x square dx. This is nothing but minus log of 1 minus x square. So log of 1 by 1 minus x square. E power log x is equal to simply x, no? So this is 1 by 1 minus x square. So this is the integrating factor. The solution is given by y e power integral p dx is equal to integral q e power integral p dx dx plus c. So y into 1 by 1 minus x square is equal to integral x by root of 1 minus x square into 1 by 1 minus x square into dx plus c. Okay, so we are getting y by 1 minus x square equal to integral x by 1 minus x square power 3 by 2 dx plus c. So for finding the value of this integral, I am making the substitution x equal to sin theta. So dx is equal to cos theta d theta. So here it will be sin theta into cos theta d theta by 1 minus sin square theta the whole power 3 by 2 plus c. So 1 minus sin square theta is cos square theta. Cos square theta power 3 by 2 will become cos cube theta. So sin theta, cos theta by cos cube theta. So 1 cos theta we can cancel. So it will be sin theta by cos square theta d theta plus c. So sin by cos is tan and 1 by cos is secant. So integral secant theta tan theta plus c. So the integration of this is simply secant theta. Secant theta is nothing but 1 by cos theta. But what is sin theta? X is equal to sin theta, no? So x square equal to sin square theta. That means x square equal to 1 minus cos square theta. So cos square theta is nothing but 1 minus x square. So here you substitute instead of cos theta 1 by root of 1 minus x square. So the final solution is y equal to root of 1 minus x square plus c into 1 minus x square. That's all. One more problem. dy by dx minus y tan x is equal to sin x cos square x by y square. So this is of the form dy by dx plus py is equal to q into y power n. Bernoulli's form. Okay. So here p is equal to minus tan x and q equal to sin x cos square x. Here n is equal to what? Minus 2. So let us take the substitution. Z equal to y power 1 minus n, that is z equal to y power 3. So the equation reduces to dz by dx plus pz 1 minus n plus q into 1 minus n. So dz by dx minus 3 tan x z equal to 3 sin x cos square x. Here I am taking for identifying the factors correctly, I am taking this as p1 and q1. p1 is minus 3 tan x and q1 is 3 sin x cos square x. So integrating factor is e power integral px. So e power minus 3 tan x, integration of tan x is what? Log cos x. So e power 3 log cos x, it's simply cos cube x. So the solution is z cos cube x is equal to integral 3 sin x cos square x cos cube x dx plus c. So totally we have cos power 5x into sin x dx. This sin x I can write it as differentiation of minus cos x, because differentiation of cos x is what? Sin x. So it is here, no? So instead of this sin x dx, I can write it as differentiation of minus cos x. Now look at this term. This is like x power n into dx. What is integration of x power n into dx? X power n plus 1 by n plus 1. So for this integration, simply I can write it as, this minus sign is there, now you keep it outside. So cos power 6x by 6 plus c. So z cos cube x is equal to this, but z is what? Y cube. So y cube cos cube x is equal to minus cos power 6x by 2 plus c. Finally, this is the last problem. Y into xy plus 2x square y square dx plus x into xy minus x square y square dy equal to 0. See, look at this problem. Here y into, here product of xy terms. Similarly here x into product of xy terms. So whenever you have y into some function of xy plus x into some function of xy equal to 0, the integrating factor is 1 by mx minus ny. So this is m. Okay, that is coefficient of dx is m and coefficient of dy is n. So from that find mx and find ny and you write mx minus ny. Integrating factor is 1 by mx minus ny. It is 1 by 3 x cube y cube. So multiply the given equation by 1 by 3 x cube y cube. So multiply and simplify. So I am getting it like this. So this equation will definitely be exact. If you want, you can check. But directly I am going to write the solution here. So solution is given by like this integral. Just for integral m dx plus integral n minus dou by dou y integral m dx dy plus c. Okay. So m is what? 1 by 3 x square y plus 2 by 3 x dx plus integral 1 by 3 xy square minus 1 by 3y minus dou by dou y of again this term into dy plus c. So integrate with respect to x. So minus 3xy plus 2 by 3 log x plus this term minus dou by dou y of, now this term is nothing but here whatever you have here that will appear here also, plus c. Now differentiate. So finally what we get? Minus 1 by 3xy plus 2 by 3 log x plus integral 1 by 3xy square minus 1 by 3y minus 1 by 3xy square dx. So these two terms get cancelled. So the solution is minus 1 by 3xy plus 1 by 3 log x square by y plus c. That's all. Thank you.